Hello friends, in my this video I am going to show you another method to plot the delta function or unit impulse function in Matlab. So as you know from my previous video that unit impulse function in discrete domain is basically the mathematical representation is delta of n equal to 1 for n equal to 0 and delta of n equal to 0 for n not equal to 0. So how we can plot the delta n by third method? I have already explained two methods, so today in this video we will discuss about the third method. So see, it is very simple. First of all, I told you to define the range of the time samples, okay, or n value we have to define, because in Matlab first step is to define n, because actually delta function is basically from minus infinite to infinite, but in Matlab it is not possible to plot from minus infinite to infinite, so obviously we have to fix some n value. So let us take n is equal to minus 20 colon 20 semicolon. Clear? First line is clear. Now write delta n, just we have given one username for the function delta n. Now here comes the shortcut trick, that is delta n equal to 0. You write this, I will explain what this is happening. This equal to operator, that is double equal to operator, is basically what is that? Suppose a double equal to b, then in that case the if you run this syntax in Matlab, it indicates that it will be 1 when it is logical true, and if it is not equal then it will show 0 output. Okay, so suppose means a equal to b means if a is really equal to b then the output will be 1, and if a not equal to b then for the simulation of a equal to b it will give you output as 0. So suppose for this case, why we have applied this syntax, suppose what is delta n? Delta n basically 1 for n equal to 0 and 0 for all other case. Okay, so see, we have taken the range of n from minus 20 to 20, that means total 41 samples. So from minus 20 to minus 1, then 0, then from 1 to 20 these samples. Okay, so basically this n equal to 0 means the output will be 1 when n equal to 0, and for all other case the output is 0. Okay, so that is what delta function. So n equal to 0 is one of the way. This is basically like conditional operator. When n equal to 0, then 0 equal to 0, that means true, that means it will give output 1, and when any other value apart from n equal to 0, suppose n equal to minus 2, so minus 2 equal to 0, this is false, so it will give output as 0. So this is basically the operation of the operator. Okay, so now delta, the function is representation is done. Then the next step, for discrete signal plotting we use stem operator, stem, stem n comma delta 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 n, clear, bracket close semicolon, clear, stem. Now you can give your wish, you can give or don't give, does not matter, x label, y label. X label will be what? N means time samples. Okay, time samples, it must be kept under single quotation, I already told several times, semicolon, then y label colon first bracket, then single quotation, then what is y label? Amplitude. So just write complete the single quotation, close the bracket, semicolon. This is the basic code. Let us check it is working or not. So just select the whole code, just right click on it, copy it, here comes the command window, paste it and run the simulation. See, we can get the exact impulse signal. So from minus 20 to 20 n is varying because we have defined the range in such a way, and delta n equal to 0, that means when n equal to 0, 0 equal to 0 satisfied, so it will give output as logical 1. So see, when n equal to 0, the output is basically the amplitude is 1. And for any other case, suppose let us take minus 15, so minus 15 equal to 0, this is false, so the output will become 0. So similarly, for any other case, when n not equal to 0, we will get output as false, that means it will be logical 0. This is also another way to plot unit impulse signal in Matlab. Okay, so this is one another simple code. Just you have to memorize this application of the double equal signs. Double equal signs is a logical operator. When it is true, then it gives output as 1, and when it is false, it gives output as 0. Okay, this operator you can use for plotting of unit step signal also. See how, you know what is unit step signal. So u of n equal to 1 for n greater than equal to 0, and 0 for n less than 0. So just what I will do, instead of delta n, just I will change this unit step, unit let us write, and here also just change the name. See how much easily you can plot anything. Unit, just write. Okay, and what is the condition for unit step? It is equal to, the output should be 1 when n greater than equal to 0. That means instead of double equal to, just backspace this, put greater than. So whenever n greater than equal to 0, you take any value, then output should be 1. Suppose you take 2, so 2 greater than equal to 0, it is, the condition is true, so the output will be 1. Suppose you take minus 2, minus 2 greater than equal to 0, the statement is false, so the output will be 0. Clear? So just for unit step, you have to just modify in just little bit, that is, instead of double equal to, you have to put greater than equal to. Now if you just copy this code, okay, just simply copy, then here clc, clear the command window, then just paste it and then run. See what you can get. See here, we are getting, as we are making the signal from minus 20 to 20, so see, for 0 to 20, that is value, for value greater than equal to 0, the u of n is equal to basically 1. Okay, so this is the code for plotting of unit step signal in discrete domain in Matlab. Okay, so this is all for my this video.